Alright.
Okay, class, so today we're going to build on what we learned yesterday regarding the Pythagorean theorem. So I just want to do a couple reviews. So when do we use the Pythagorean theorem? Anyone? Yes?
We use the Pythagorean theorem when we have a right triangle.
Okay, so only when we have right triangles, they don't work in other situations.
If we can make it a right triangle.
Okay, alright, so that's good. Alright, so we know that we can use it for right triangles, but I don't want to do this I don't want you guys to do it just because I'm telling you so. So we're going to work through this and find the proof and use mathematical evidence as to why the Pythagorean theorem works for these situations. So what we're going to do is we're going to hand out our first worksheet. It's going to be proving the Pythagorean theorem. I want you guys to read these over individually and come up with what important things you're reading, maybe ideas that you're seeing. But before we get started, I just want to go over and make sure that the whole class is sure what a proof is. So does anyone want to give us examples or keywords about proofs that you guys have learned in the past?
Evidence.
Evidence, okay, that's a good one. We can do just adjectives, anything that comes to mind when you guys are thinking about proofing. Justifying, okay.
Argument.
Argument. Yep, all these are really good. So, I mean, it's good that we all have the gist of what a proof is. So, let's go back to the worksheet. Individually, let's read this we'll give you about 5 minutes. And let's highlight those words, see exactly what you see is important on that worksheet, and try to work through it by yourself at this point. And then we'll come back together and we'll be putting you in groups.
Great, so work through it for 5 minutes and then we'll be partnering you up after those 5 minutes. See if you can figure this out. Oh, and to do it, so we have grid paper up here that you can use. We have rulers. You can also use in Blackboard. You could use any from the first class of this semester when Dr. Frank posted the links to the geo boards. You could use any of those if you want to, or grid paper, markers. There's markers if you want to use different colors. A ruler if you want to use that. So whichever way you feel you want to go about doing this problem. Yeah. So that's what you figure out is how are you manipulate this picture to get to this point.
How are you guys doing?
Oh, fun.
Good. Yeah, still drawing.
I guess it depends on if I understand the theory. But, I mean, it sort of seems like what he did was, it's based on these pictures. If you like cut the triangles.
Yeah.
These two
Like now it's just filming a blink. Like, is that better?
Yeah, that's probably.
I mean, if like while we're working in groups,
Yeah.
better than
I'll
just
slide
filming
over.
like
So
a.
yeah, because if
like-
not, you're just gonna get my sweater. I'll slide over.
So are you using different colors for you to
That's
show
Yeah,
the
so I want to this one. This one.
I'm trying to.
It's hard.
I mean, this here definitely seems small.
Combine them to make
that's
a
just
third
a
color.
not drawn to scale issue.
These ones are the same orientations. You should slide.
You should be able to slide. Yes.
Definitely sometimes it's nice to have like what's happening in the group.
But in terms of
Yeah.
like, why would this hurt? Sort of thing. Because
This triangle.
yeah, actually
Piece
that
like
that doesn't work because
so
this is length C, but this would be
Yeah.
length B. So this picture would be smaller.
So do you remember what it's called
So
when
yeah,
you
that's fair.
when you move this triangle over here?
sliding.
What's a we remember when we talked about transformations, all the different types of transformations.
I see.
It's not a glide. It's not glide.
Yes.
It's glide.
Or a translation.
That's what we're looking for. Translation.
What are you like
Remember?
seeing
Can
the
we
main
move it over?
difference from this one to
Yeah.
this one so far?
Okay, so that's not, it's sort of sliding. That's why he used the word slide.
Exactly. Exactly. So that's what he meant by slide.
Outer part.
Okay, and
I mean, this
then
part
now,
inside seems to make
now
it
we
work.
have what he has here, right?
But in
So,
the second one,
okay,
there's two
then
squares
it
that are
says
different.
using the line. Okay, so
So then this inside has to be the same.
write down what you know. Then.
So you're saying that these two have to
Did
equal
you
this
redraw it yet?
inside one so we get the
Because,
same
you know,
area?
Yeah, redraw it. So that's your
Same
first step.
space.
So
Mhm.
Spread
this
it out
is
in a
just
different
sketch.
way.
We wanna make it
Yeah, that's a
flat.
good thing to pick up on because it's good that you're seeing that sometimes you think that these two squares might be equal,
Right, they are both
but you're
big.
seeing that we're trying to get the same area
Right, but
total.
yeah, because we're saying these just moved over.
Okay, so it looks like you're on the right path. So what we need to see exactly is maybe where the B and A's end up once you
Right,
transition it to see what we're combining to make an actual math equation, which we're definitely going to get into during our class discussion. But it looks like you're on the right path so far.
Do you think it's a square?
Looks close.
Yeah.
And
How can you be sure it's a square?
I don't know. I'm just saying that. It looks like
I just
Well,
measured
I mean,
it,
this just
so
doesn't
it's
work.
like five
So
five
find your right,
same.
and that's how you figure it out.
It's,
Okay.
it's the same. Is it the same length?
pretty close.
Pretty close.
Okay.
I mean,
Like a hand
So
drawn
this is not drawn.
square.
It's not drawn to scale.
Yeah.
Are you telling me that?
these just
Oh,
don't
it's
work.
a square.
You can just jump in with her.
Yeah.
I was gonna
It is
try to like
square.
redraw it, but even like
Yeah.
I used lengths that I know
Okay,
would
go ahead.
give me a
What happened?
What happened to your? Oh, okay. It I don't know if you all have.
It records it, you know, when the
Okay.
screen goes out. Yeah.
Okay.
We are working on a lesson for students that got in. She's starting this, so you can work with her to see.
So this is
like that, right? Then you end up with like a weirder open region here. So I feel like this diagram is just
How do you know that that's?
a good representation. Like this one.
Oh, okay, so my match right.
oh actually it's
Okay, that's good to know, yeah. So you went about figuring out that.
So like how else could you translate these different shapes?
I was like, you just mix that one.
So
this. It's an A.
Okay, so
my
got
first
the-
thought is to like not to see it should work, right? My first thought is to like just move them inside the square. But I'm not sure if that will actually work.
Yeah, why don't you try that?
Yeah, let's see how that goes. So,
I'll come back and check.
Okay, so now with your labeling, what are we finding?
What have you found?
I'm trying to recreate Marty's diagrams here in my graph. So I'm trying to figure out where each of these goes. Like I figured that this will be my first triangle, and that'll go here, and then I'll take this one. rotate
So
it,
what do we,
so
so
this goes
you
here,
said this, we know that
and then
these two
the name
diagrams equal each other.
Right, because if
So
you
like
have this big one,
move this
big
one
one is a.
down, and then to this one goes like this.
This one's broken up into c squared
Okay.
plus 4 times 1/2 right there. This is an algebraic proof. Now I'm getting away from myself.
No, but you're using the knowledge that you know about
So I know that.
variables.
Hold on, I want to do it a different way.
Is there more graph paper?
I'm gonna say
I lost mine, so
I'm
I
gonna
probably
say
Tracy probably
that
her.
So
this
now we have
this white space is the big space
No, actually, this
minus
is what
the
you
little
guys
guys. Yeah, minus the little guys. Because we want to take them out. So it's
8 square.
yeah, 8 squared.
Minus 4 times 5 times 3 divided by 2.
Yeah.
Which is where C squared.
Okay. So that's gonna be 64 minus 34. Okay, so that's 34. And then if we do the same thing over here, we could either do the big space or we could just do 5 squared plus 3 squared.
So where are you getting the 5 and the 3?
Because that's the side of my triangle that I had over here.
Okay,
So it was broken up, my 8 was broken up specifically. Because I was looking at, so this was the white space here, which was the big guy minus the little guys. But the white space over here is broken up into 2 that I can count.
Oh, okay.
So I was just, counting. Which was
So this is
25.
not C.
I had an extra square.
Yeah, that's not
okay.
C.
So
that's
what
B.
part do you think was C?
That's
You
right,
thought that this
or
was
if I
C?
actually just did something.
Okay, well let's think
But it's
about
not.
how we're shifting.
This is C.
Yeah.
Let's see, 5 square, 5,
I don't
5.
see you shifting.
So
Oh, I see you shifting the triangle, but I don't see. Okay. So
Yeah,
the white
so
space.
this one just came down here. These guys went over to the right. So the white space just got redistributed. So they both equal 34. So I was right when I was saying that it just got squished in a different way.
Yeah, so we are correct that they are equal, so we know that much. So it looks like you're on the right path for writing a formula for proof.
Okay.
But since what is the formula for Pythagorean theorem? Because we're trying to prove that right now.
But the kids already know the Pythagorean theorem.
I mean,
Yeah,
the
we learned
diagram
that
is
last
accurate,
lesson.
but I'm
They
not
wanted
sure
it, but
what I should be getting.
Math, we don't know why it works. You guys just know it works for right triangles right now.
Because
So if we're trying, since we know the proof is 2, we need
the
to
area
prove
of
something
the
correct,
four
right?
is
We need
is
to make sure that our argument.
That
So
C
that-
square
Before
plus
triangle.
B square plus B
So
square.
yeah, there's one less
A square is here. B square is here.
So
Okay.
Yeah.
So
this is B squared.
I can't jump off.
So we want to prove that C square is equal to this
Like that
2,
would give
but
me.
you
Right.
just
I mean,
proved that
this like.
So I proved
area
it
of
in one
these
case.
is equal. Oh,
Yeah.
So right now you guys have proved that in both ways that they're shifted, their areas are equal to each other.
right.
So we know that much, but
So we know that C square is equal to A square plus B square.
so since we're talking about proving the Pythagorean theorem, which we know is A squared plus B squared plus C squared, the steps of a proof
To
are
So our Pythagorean theorem.
what you start with.
Okay. So we start with these big squares.
Mhm.
So that was my
So.
A plus B.
Which you had that.
As length, A plus B square minus, and we also know that the inside, the white shape is equal to C square.
okay.
So
So
we know that.
so we're gonna write this just out in variables.
But the.
Yes, let's do it in algebraic form. And let's see where that gets us.
I would write also that
What is this?
C square plus what we also know is that A plus B square is equal to A times B divided by 2 times 4 plus C square.
Right. 2 ways to write the same thing.
Right. So
Okay.
because we want to reach to the conclusion that C square is equal to A square plus B square.
So that's what the first square
So-
gives us.
Now,
I'm sorry, I just wanted to.
Yeah. So
do you want to try to solve this like algebra?
I don't think you can solve it because
So-
we have
Yes, you
one.
can. A square
Yeah.
plus
Okay,
2AB.
so we
plus
want to
C square.
distribute.
And now, yes, and now you're going to
This is not square.
and then you have the
So what is the value?
now this is 2AB,
2AB, right?
and this is 2AB here, so we can
So
How do we
Subtract from both
subtract from
sides.
both sides, and now we have A square plus B square equal to C square. There you go.
Yay.
Okay, we're gonna have you guys later share this with the class so we can see if anyone had other mindsets. But if you guys want to keep working, there are other ways for proofs. Let's try to see if we can find.
So can we use this one? No, that one doesn't have a C square in it.
Okay.
Let me bring you guys some.
We can have to go from here to here. So you all have A square,
I know.
A plus B square,
We started. Those are 2 ways to write it.
So why don't you start now from what, like from C square plus 4 plus 4 triangles.
Well, I
It's
mean,
gonna be equal to
Yeah, it's just gonna be another way to write it. Because no matter, you could start with any of these. We could
So
also
this,
start with.
this is rectangle.
Yeah.
AB.
It's fine.
So
Oh,
the area
yeah,
of the
two of them.
rectangle.
Yeah,
and
yeah,
the-
of course.
And this is the square. And this is the area. So this is the area of the whole thing.
Great. So you've just shown
Put the diagram here. So I want you guys to
how
since you
this
guys have
square
already
and
gotten
all
that,
these
so
areas
out
out to diagram here and
What
to A plus
are
B squared.
similar.
So now your next step is to figure out if you were to prove this to somebody else, how could you do that? How could you
Yeah, that's the problem.
write it out in words? Could you use a picture to do it? What do you guys want to do? What do you think?
Can you tell me this? So to prove it.
So we understand how we did it. Now we have to show it to another person. How would you
Could we just
So let's go through the questions, just so we can see where they want us to go. What type of triangle does Sophie use? It looks like
So I found another way to put them together,
like
but
both
make a
of the
square.
legs are the same size.
So,
Maybe they are.
Which we're going to do
so what did you do?
I just copied exactly what.
But then
I'm just proving. I'm totally different. Totally
Right.
Because that was
This
this
was-
way, right? Yeah, now
So
we have
this-
to do our
But we're
own
using
way.
this
This is like
diagram,
5.
remember. So for
Which
this
diagram?
number
This is
3,
Oh, the
so
same
using
diagram?
these
There would be one
diagrams,
more.
you
Oh,
want to
okay.
construct a proof.
This is like 5.
So,
So like,
so we're gonna
I didn't have
say-
colors, so it's hard to see, but I redrew it as well. If you did the square to
So we know
length, so like the square goes down to
I
like
like that
this
thinking
length right
right
here,
now.
but the
Starting off with
rectangle
what we
stop.
know.
so we know that
You end up with like this weird.
this
space.
big one
Sorry,
is
I have
this
it like
big
trying to
triangle.
reverse my
And
process.
we know
Where exactly?
triangle. We know,
2, 3.
do we know the area of the triangle?
Right, but the square would be
yes. Yeah,
this length 5.
you know
How
it.
did you construct this?
But see, we don't need it
Like,
because
what do you mean?
these triangles are right
What do you mean?
here,
Like,
right?
like I
Right.
And this
So
is
1,
the
2,
blank.
3.
right. So like I took this
Oh,
triangle,
we have to
right?
start
Like
with
this
that.
one from here.
That's
right?
why
And then
Right.
I put
the
it here.
leftover pieces
And
that
then I
are
took
not
this
used
one.
for triangles.
This one.
Right.
This one.
C square here,
Right.
but it
this
is
one.
also an A square
And
and B
this
square
one,
on the
this one.
Right.
Right? Because that makes this rectangle. And then you can do the same one like
Okay,
this
so
one
I see.
and those two to make these.
Right.
So
But
is that
the
a
problem
proof?
with like this diagram, right,
That's just
is
my
that it
observation.
assumes that the side length
Is that an
of the
argument?
square, so
Or is
C,
that just stating what's
equals
happening?
B. But that's
So
not
it's
true.
stating as
Like that
what's
can't be
happening
true.
about the B, you know,
Sorry,
Because-
I got lost. I don't think this is supposed to be C.
So no, we have to know. Okay.
Why do you think
so
that's
we know
supposed to
that
be B? We know that it's
this
C, it tells us that the side of the square is C. It tells us that right here.
so these are
Right, but I
similar
think it's a
no, they're
problem
actually
with the
rectangular
drawing.
triangles.
I think this and
Yeah.
this together
Yeah.
is
Yeah.
C. Or like this and this
So
together.
um,
If that's
Well,
sorry, this area and this area is supposed to be this one area.
I agree, but
So what I'm noticing is if these words
the same length.
make this from
Like
I'm
this,
gonna-
this triangle doesn't go into the big one. Like my triangles just are all different shapes.
So here. Yeah, so all the triangles, not all of these are right triangles. Is that what you're finding?
Yeah, so like I have like some little triangles over here and some big triangles and like
I'm making
so
a
I
right
can't
triangle here with different
see
lengths.
the same thing she's seeing. Because
Yeah.
she
Trying.
sees that like there's 4 of them here and 4 like here.
So what are you seeing? Do you think that these two triangles are equal?
They have to be, right?
Yeah. Okay, so that would also mean what does these sides equal?
They have to be. Also be. These are also.
And what are they forming in the middle?
I mean, I guess that's their own hypothesis. That's
Or what are the the 3 squares forming in the middle?
Why do they have to be equal? I haven't got it yet.
Well, so what I
Well,
was
what do we
doing
know
was-
about squares?
I get confused
Oh,
because
okay.
this is
Right?
Yeah.
their area
So
is their
I see
side
the square.
squared.
Mm-hmm.
That's what I
Okay, well, I mean,
Yes,
Right.
the square has to
But
have equal
I was
sides.
thinking that
Yeah,
that was
A
But why
is
does
B.
A have
part
to
of
be
the
equal to B?
diagram that had to
I think it's
see
just for the
rather
vision.
than being like this is like
It's
a
so
open
that we
space
can
and
see it. We can just slide them over.
So okay. So I
So
understand what you
she's
did.
saying
Right.
the area of the small squares is a squared plus b squared.
25 minutes.
And then a
25.
Well, I just tried to
that there's
Yeah.
two triangles here, two triangles here,
And do you
and
want
four triangles here, so 2 plus 2 equals 4.
I'm just wondering if this would
I
work,
gave them
if this
examples.
wouldn't be equal.
Oh, they
I
finished.
think it would.
Yeah.
You would have to end up like having a grid paper, like on the whole thing.
Yeah.
You know, you'd have
That's
to
what I
like
was
break
trying
it
to
up
say.
really small,
That's exactly what I did.
and it might be hard to actually calculate because one of them was on the diagonal.
So let's do that now.
Yeah, that's what we were.
Yeah,
Just
okay,
obvious
let's do
squares.
this
I'm
now.
gonna transition to that now. How do I put the document?
Okay,
in?
let's stop here. We're gonna get back as a class and we're gonna share the ideas that we've come up with. Okay. Is everyone ready to pause and come together for their group ideas?
Alright, so we want to take a quick break. We just want to talk about some of the thinking that we've been doing. So we want to make sure that we all understand how diagram 1 became diagram 2. Okay, so that's our first step. So, do I have a volunteer who wants to come up here and show us maybe the first step or one of the steps that was taken that Marty used to go from diagram 1 to diagram 2? You were just explaining it to me. Come on, you know it. So we're just, again, working through how these diagrams were put together. Okay? Then we'll come and share our ideas that we have.
So the way that I saw it from here to here, that Marty did a line here, right? That he slide this one over. So he took this part of triangle and it's this one, right? And he put them together, right?
Yeah, so you can go into them.
Yep, you wanna show them?
I don't know. So, the way that I saw it, that he divided it like this. He put those. I don't know.
Can you help? Yeah.
So I can tell you the way that I after talking to John how I see it.
Please.
Basically the way I saw it was he took like this triangle, like if this was a piece of paper, this big square, he like cut this triangle off. And he cut this triangle off and then he pushed them together and put them together.
Okay.
He made that rectangle. And then he did the same thing with these two. He cut these off and put them together and put that one here. Okay. Was the way I saw it.
That's the way I see it too.
And then you have like this space and this space. And so he's saying that because this length is A, that you know from here, and that this length is also A, right, because you know from there, that A times A gives you A squared for this like space.
Great.
And then same thing, you know this is B from this, so this is B, and you know this is B from this. So B times B would be B squared.
Okay, great. So Ellen walked us through how this picture was constructed, and what he kept saying over and over again that I heard was, we know this length is B, we know this length is A, so therefore we know this, right? So already Ellen is working through those proof ideas, right? He's telling us what we know and how that leads us to a conclusion. So now what we're going to do is we're going to put you've had some time to think through this problem, but now we're going to work on actually putting together a proof in a group. So Maddie's going to tell you what we're going to do.
Yep, so we are going to hand out poster paper and we're going to put y'all in 2 different groups. And you're going to work with your group for several minutes and try to actually come up with a proof. So we have the construction now from our worksheet and we have the Pythagorean theorem what we're actually trying to prove. And so, we want you guys to fill in the steps. How we get from the diagram and our ideas to this formula, a squared plus b squared equals c squared. Okay, so for our
We want to start right with what we know, though. Maybe talk about what we know.
Yeah.
Go over that with the class.
So to share maybe what they know to begin with or how we can start?
Well, you know the side length of the square is a plus b.
Okay.
We also know that the white area on the left side, it's the big square minus the area of the 4 triangles.
Okay.
So that would be that the c square basically is going to be equal to a plus b squared minus the 4 triangles. So that's what we know so far.
Do you want to come up and write this? What you want?
I don't know. Can you?
Okay.
So then it just becomes you're saying like cut the triangles off. It's maybe not the best vernacular.
It did. Brilliant. So that's improved.
Does everyone agree with what Patricia's writing and saying, or does anyone have any objections?
So far, so good.
Okay, I think that this is a good stopping point, so we can like split up, right, and go into what she's kind of like started us off with the knowledge that she has, but let's go into groups and see how we can build on this to get the proof down to a squared plus b squared equals c squared. So we have the groups. It's going to be Patricia, John, and Saba together, and then Alan, Rachel, and Dr. Frank together. And you, sorry.
Oh, I know you're in the first group.
So in
Alright, so do you guys want to get together? Remember, are you guys all good with what groups you're in?
I think.
I'm just gonna take this picture.
I third.
Alan, first group, can you repeat the name?
Patricia, John, and Saba.
Individual.
And Amir.
I know, that's what I'm gonna do.
Oh, you're
Oh,
I'm sorry, I didn't hear whose group I was in. I'm ready.
So they're coming up here, like, and Dr. Frank.
All right.
Okay, so you guys need markers.
Oh yeah, that's right. Those are like posters.
What grade are we in?
What?
What grade are we in?
You guys are in high school.
Okay.
Yeah, high school.
Okay.
That's a very wide range.
Yeah.
Whatever speed you're on.
No, because I'm just wondering. So here I go. Right. I'm just wondering. So, could I just say, here's what I was thinking.
Okay.
I was thinking. So we knew when we slid everything around, like the squares stayed the same. So I was really just looking at the white parts here, and so a squared plus b squared equals c squared. Is that sufficient?
That's what I was thinking.
I think we'd have to build on that further because that's showing us with just a diagram, whereas if we go further, we want to have mathematical evidence.
That's not mathematical evidence.
We're showing with a
we just want
formula.
a written proof. I think,
Yeah, a written
right? That's what they want us to do.
Right now we're at the symbolic,
It's-
but I want to
Okay, so you want us to do it with the symbol. Okay. Okay.
So we get the picture now. We need to
We get the picture.
write it more formally.
Okay.
I wasn't even trying to do that. Okay.
Okay.
Is this our poster
So
board
let's see.
or
We know.
poster?
So you all took
So we have to
the area of the big square.
what we know.
So Patricia,
Minus-
we did.
Okay.
I thought about it, and like we basically found out a bunch of different ways we could
Equals the big,
make
right?
relationships.
Equals the
You guys got so
like-
much farther than me.
So what is a plus b squared?
Well, one of the ones that
Okay.
you could do is that you could look at how you could think about the area of the big square. And so like the first one, the big square area equals a plus b squared. But then you could also think about that square as c squared plus all of these triangles. So I
That's
think
how
that
I
one's-
thought of it. C squared
Yeah.
plus 4 times 1/2 AB squared.
Yeah, I think that one's my favorite. Cause
Oh,
the
but see,
other
she's
ones,
subtracting and I'm
Yeah,
adding because
I
I
mean,
just
you
it's
just
the
move
same.
it on the other
yeah,
side. It's still the
same.
same.
square plus the
Sure.
4.
I like that one.
I did it differently, but you did. Oh, it's okay. That's fine.
Yeah.
So hers, let me see.
So yeah, all
Okay,
that
so
we
she
did-
took hers out equals C squared, right.
All that we did at that point is just distribute
The
it.
area of these two is
And then
I don't see how hers relates to two figures. I see how
That's what
hers
it is.
just
we're just it starts with the
Okay.
first.
hers
yeah.
just works
That
through
was
the first
yeah,
figure.
but it
hers doesn't-
works, though.
Yeah, it works.
Right?
Yeah, it
I was
just
confused
doesn't.
about that too, but I don't
This is
know
the inside.
what we
So
can
do
do
you
with
have
that
a
one.
way that relates the two figures?
Uh-huh.
Okay, so what is different between yours and hers when yours is relating the two and hers is going off the?
So hers is just talking about like what's left when you take away the shaded pieces. Where mine relates like right, you have
So you're making
I talked about all the components that make
of
up the
that are
big.
in it.
So this is really like the quantity of a plus b squared equals the quantity of a plus b.
Yeah,
Yeah, where hers is just looking at one
hers
figure.
is just looking at the
But
first
wait,
one.
wait.
Right?
So you're still basing it off of these
But
two
these they're
big
the same
squares
thing.
are the same.
Yeah,
so you
that's
could
just that
add
they
up.
occupy the same thing.
You could add up. So on this one we have our 4 triangles, our 4ab over 2 plus c squared.
Which
Good.
is what
So
I
on
did.
the other
What I'm
side,
seeing-
Right, that's what I did.
4ab
What I'm seeing
over
with
2
your guys'
plus
chart
a squared plus
is
b
that
squared.
You
And then these guys just go
use-
away.
That's what I
This
have.
one.
Yeah.
Yeah.
You just
quick.
use this square. Is there
Simplifying
a
it out.
way to
Yeah.
Okay, I mean,
use
do you guys
this
want to
group
write this down on your
both of
poster
the
board and we're going to
squares?
hang it and have the
Like
other
the
group
smaller
see what
one
they
and this
came up
one?
with?
So is there a way
Any
to
other
is
type
there
of-
a way
Sure,
to say that
sure,
this
sure.
one
Okay.
is equal to this one?
We can get
Are you all sure
I don't
it's
know what colors I
recorded?
want. Okay, how?
Allison.
Allison, y'all, you sure this is recorded?
I'm sure. I just
Okay.
did it earlier today.
So,
and it's-
okay.
Well,
Go ahead.
I don't know. I'm having trouble with it just because
Yep, it's still going.
it's hard to describe
Okay.
it, especially without.
Can we just say like diagram one?
labels, but I was thinking like the step the way that I had thought about it was you move like you move these triangles together so that you have these rectangles,
Right.
and then you arrange these rectangles just so
And
and fit them inside like imagine that you keep this like
I would like to do like.
I'll put it up.
right or you don't even need that you can just match up these rectangles corner to corner like this and then this length will be B and then this length will be A so this will be that and then this will be B and this will be A so this will be side length A plus B and this will be side length A plus B so certainly these squares are the same.
So how are you gonna draw that?
How to write the
how you all
I don't know.
I think we should like what we know like
I got,
here
I got
equal to this instead of saying that this is
We
equal
have
to
to know where to
this.
see here,
when it
right?
said,
We
would
just
you
say
slide
what
the
this
triangles you guys
we
I
bring
was
these
trying to
components
slide this.
and we put equal to this
Well, I
component.
started back in
And then see what we can make from there.
You can because of the way it's colored that those two
So we can
squares
start
are
with maybe like since
Right,
big
that's
square
exactly
is
what I
equal,
did.
this big
It's
square is
I
equal
did
to this
that.
big square, so we can
Was
start with
that.
this big square is equal to this big square, and then we can
Which doesn't make any sense.
break it down
Let's
and
go see.
then.
That's a great idea, yeah.
Right, which is not what I did.
But because of
But
the
isn't
other pieces
this
color-coded,
these
the
two
first one I
pieces
first looked
together?
at, I was like,
Right?
And then
So this is
Yeah.
showing,
That's
so
about
right,
it.
we have
Yeah.
C squared here is equal to A squared plus B squared.
were
We don't
only
necessarily
90
want to
minutes, so
show
it has
that
be C
the
squared.
two
Those two pieces, those two,
squares
like,
are
square.
equal.
So I spent most of my time trying
We
to
want to
figure out
show
how
the
I could,
Pythagorean theorem.
get that to work.
That's what
And
we're
then
proving.
when they let us
We're
play
not
for a
proving
minute,
this square
Yeah.
is equal to this square,
Then
right? We
No, no,
really want
no,
to
no.
focus it on A squared plus B
But
squared
this
C
small
squared.
one
Yeah.
square
Yes.
is divided into these pieces.
Yes.
And that's how we're gonna
I didn't
prove that
get
it's
that.
Exactly.
Pythagorean theorem.
Exactly.
That's what I'm
so
saying.
that's yes. So this first part that you have here is proving
I don't know how
this,
this-
the area of this square. But we want to prove the Pythagorean theorem. Exactly.
So because we know these two pieces equal to this part and these two pieces equal to these two, and we know this is equal to the empty space,
Exactly.
and that's how we're gonna prove it. It's
Exactly. Right. So how can you break that down?
Okay, so here's what
Got it, Vanessa?
I was trying to write that and I'll like move my
Our
entire
group does not.
So I was trying to do the like
This part equals this square, these
column
constructed into this
We need
part.
maybe like
Column proofs.
and
4 more, 3 more.
Okay, since we saw the other group working, do you guys want to? I have one group.
I think the way that I would do
But
it
is this wrong?
You can give them the it's on the desk.
That's
The extra
interesting.
Sorry, this
So,
is like
I had
I wonder if Patricia was right.
at least I was
What is it? What was your-
so
Yeah,
I
how
had given
was hers
you the
or
picture,
So this
right?
is just the algebra.
And then the first step I think is like to move the
Um,
triangle.
So I'm gonna give you guys this.
Three.
Rachel was working on this before. This is another sample way of someone used to prove
So that
the Pythagorean theorem.
Alright, so I'm gonna
And it's
say
different
move
than
triangle
your guys'
3
a
to
little
triangle 1
So,
so they fit into a rectangle.
so if you guys want to review
4,
that, look at the questions,
triangle
kind of see
2.
what her thought process was, and if this
So
is the way
there.
that you can also do that.
Hypotenuse, touch,
So I have one in my
and they
If you ever
form
come by my room, it's my main one.
rectangles.
So
So then the picture,
So you like fill up these two
Now
channels.
would be like, so now we've gone from like this
I would like that because I like shit.
I mean,
to
it's a hit with 7th
this
grade.
percent, this percent, so then we have this.
There's a whole article that's like on NCTM, it's like a little guide to it. So what type of triangle should
You move this one close to this one, but that rest is still the
So
same.
I can go for triangles.
Is he trying to?
No, are we?
So what she did.
So then, so
Or
so this one moves down here,
Yeah.
and then you,
Oh,
so what you're left with is
should it be
this.
lined up?
But then there,
So
I think
yeah.
it's.
So
I mean, I
then,
think he's just doing the draft,
But
right?
that
So
doesn't.
figuring out how to actually put that into.
Right.
Yeah.
yeah.
these
So then what you
triangles
have is like
Hmm?
this.
That's what.
You've got like this down here and this down here.
9th
So you're just
graders.
putting like this here on the bottom.
Right,
Okay.
and then you move
So
this
what-
I'm
rectangle
not sure
up
that you would go.
by,
What do you really need to move it up?
you need to move it up by A.
Try it out, like really.
Or at least we want to move it up by A so that we have like
Okay.
this situation.
So you're trying to explain all the transformations that are
Right.
happening.
Yeah, at least in
So
our
as
picture.
might, but not like that.
So
ninth
maybe,
graders, I'm not sure that we would know.
so we're just gonna say that the reason
I feel
is
like-
that,
I mean, the thing is, this triangle here.
I guess we don't need a
rectangle
reason
with
for
A
why
and
we do
B.
this.
We're just say we're trying to
If A
puzzle
equals
it.
B, this is
Okay.
also A, B, and C.
Yeah,
These are
okay.
all the same triangle.
Right. If
Just
A and
like
B are the same
everybody.
length, it'll work.
Good.
And then
Translation.
I feel like I'd be
That's
worried
a
about
good
using that though because it could create
Rectangle.
some misconceptions.
Oh, yeah.
Because if you
3, 4.
teach this to students and they think, oh, I
So that
can
would be
do
like this
this, and then you
rectangle
give them
up.
a triangle where A and B aren't equal,
by
and they
A
want to go to
is-
this, it doesn't work.
And I guess that'll be
Then
translation.
I feel like they're just either going to
Okay, and so now we have,
work off that misconception.
This
So
or
do you
they're
guys
gonna see it
understand
doesn't
what
work
he's
and then
saying
get
by
confused as to
translation?
why.
Yeah. So you get that?
okay,
Yes.
In
Okay.
context,
Um,
I'm not
going
seeing how
through
you see
all
the,
the
oh, yes, it's a
verbs,
translation,
or
but
not
on the
all
other
verbs,
one it's
but, like,
also a
different
translation.
ways
Yes,
of
it
proving
is.
something.
so this would be
No,
like,
Right.
actually, here
So
it's a
see, like, there
rotation.
are different ways to
Right.
do it.
So
Yeah.
rotation,
If
good.
you just wanted to show
And so
this
then
and you made
step
clear
3
that
would
A
be
equals
like,
B, then you could certainly use this.
What type of triangle?
like this.
You like reverse
And
triangle.
then you have to put
And
it
then we know that
Right.
this is B,
Oh.
so, and this is B. And we know that this is A.
So this is kind of an analysis
is like a-
of a
I don't know how to describe this, but we know that like, we know that this length is B,
Mm-hmm.
and we also, since like this is a rectangle right here, with this
I mean,
being A, we
partly
know that
just from if
like,
A equals B.
this length here is
which
A.
you
If we
need
were
to
to,
specify that.
if we were to
Yeah.
drop this down, like a straight line, then we would have this
And then
length
she
as
also
A.
doesn't really explain
And then
her
since
core
we know that
triangle.
this length,
Yeah, because
uh,
I'm sorry, I'm thinking back.
sorry,
like,
we know
what
that this
makes
length is A as
sense
well.
that we say that,
So we
like,
know
the
that
same amount of
this over
space,
here,
the same amount of area was
Right.
preserved, so A squared plus B squared equals C squared.
So then it
right?
would be.
So she would need
squared.
to, yeah, I was gonna say she'd need to
A
refine, there you
squared.
go. She would
And
need
the
to
way that I
refine
was
hers
trying
in
to
some
say
way
that,
to, yeah,
Because you
make
know,
it.
3 and 4,
Mm.
right, you two are
Right,
equal,
2
right?
squared.
So and this, and 1 and 2
Because if you
are
labeled each
equal.
one
So
like this is the area of each triangle.
This,
Mm.
this area of this square.
So Sophie, we
down
need to go further.
to this
Yeah.
area.
We've decided.
Yeah.
Yeah.
More steps.
So the area of this.
So
right
what
here
steps
and
do you
this
think she would have to
square,
add?
right? And the area of each one
could say-
separate.
She'd have to
And
say
There's
something
something
about
that
just
Jane
how
Metric
she
way,
needs
yes.
for
We
triangles.
got
Starting
some,
the
like,
translation
different
and
kinds of
translation.
For
So they
instance,
do it
before,
algebraic.
before we
Okay, so there's two.
Because at that
so
point, you're
let's
not really sure what.
Yeah, so we can bring it
Yeah.
back. Do you want to leave the
Rectangle.
Yeah.
Like, I was like,
How does she
these
do
are
it?
the-
9 triangles, right?
So how would you
Why
guys
don't you
do
do four
it to
triangles?
make it better? If you guys,
Right.
Yeah.
I think it's pretty
Right.
fast to start
Okay,
with
Now y'all aren't quite done yet, but it sounds like you have the thought processes there, and this group is done, and you two did it very different ways. So we're gonna have one person from each group come and explain their proof, and then we'll have someone from the other group come and explain it, and we'll talk about how those are similar and different and what we like about them.
so do we have a volunteer from this group since you guys completed yours? Okay.
I'll try my best. Okay, so in our group, we started off with what we knew So we said that the diagram of the area diagram 1, this diagram, was 4 times 1/2 AB. So the area of a single triangle would be 1/2 AB, and there's 4 of them, right? And then plus c squared, which is the area of this inside square. So that's the area diagram 1. And then for diagram 2, the area, we said that it was, again, the 4 times 1/2 AB, because we have the same 4 triangles. And then we said that was plus a squared plus b squared, because this is a squared and this is b squared. So b squared plus a squared plus the 4 times 1/2 AB gives us the area of that one. And then, based on this diagram, we said, well, diagram 1 is equal to diagram 2, so we set the equations equal to each other, and the 4 times 1/2 ABs will reduce, which leaves us c squared equals a squared plus b squared.
So you guys used cancellation and also similar shapes to prove that you can simplify it down to c squared
Right.
equals a squared.
Well, I mean, there might be a better way for us to make clear, but like you know that these are the same size because if this is a plus b and this length is a and this length you know is b, then you also know
That's what you.
so like you know those are the same. That's why
What did you say?
No, that's what we.
So this group initially started with a similar way of doing that, right?
Yes.
Yes. But then they decided to go a different way. So John, do you want to explain your second way?
Maybe.
So they don't have it on their paper
That's
yet,
kind
but
of
it's on John's
complicated.
paper.
We didn't really finish, but we were trying
We
to,
did.
and maybe.
Yeah,
we
do you want to put it
started
on the
with
document?
Yeah,
the
that might
but
be
then-
easier.
Does someone want to go up and help explain everything?
Or you can explain.
You can try.
I think you really need it.
About here, so we have our and then like a 2-column. Okay, so our like given was just the picture on the left here that we started with, and just for ease of like referring to things, we labeled the triangles and like the big square just so we talk about things. So our first step was to move triangle 3, this one up here, down to fit in with triangle 1, and triangle 4 down to triangle 2, so that we made rectangles. And our reason was translation, not really much of a reason, but for the picture. So this is the thing that we started with, and then for step 2, you moved this down here and this one down here to make these 2 rectangles. And then our next step was to move the rectangle with triangles 3, 4. So this one right here, which currently is right here, we moved it up by A units. And down to this one right here. So we've got this rectangle and this rectangle. And then let's see. Oh, so then we said that with them in this formation like this, they made this square with side length a plus b. And we didn't really have a reason for that yet, so we kind of stopped. And then I think after this we were going to say that because of the lengths of these rectangles, that this square here has side length. Well, this is length b and this is length b because of these rectangles. And this is length a and this is length a because of these rectangles.
So the area of both, he built
Right.
the second square with rigid motions.
Right. None of our like rectangles that we moved around were overlapping. The basic idea was like this big square minus the area of all these triangles should be c squared. This thing here, which we found out was the difference was c squared plus x squared.
Great. So group 1, what do you guys think about John's proof and how he did that?
Does that count?
What do you mean? Does that count?
Does that count as a proof? Because that was my question. I was like, well, if I know that I move everything around, but the squares are the same size, I conserve areas, so I know a squared plus b squared equals c squared. I was asking if that counted as a proof.
What do you guys think? Who can answer that? Does that count as a proof if we just know that the area has stayed the same? What makes it a proof? What do we think?
It needs to be generalized.
So is what your method is that valid proof? Just because
If you reconstruct a figure, isn't that a proof? And you didn't change anything, isn't that proof?
I'm asking.
I'm
You're a nice writer.
I mean, doesn't it count as a proof? That's good. Does it?
Why do you think it counts as a proof?
It is a proof. You justify with the
Okay, so there was a lot of justification happening.
It's absolute proof.
Yes.
Absolutely.
Yes.
yeah.
But I like the I actually like reading transformations as ways of proving things. I thought it was a cool way. I think a lot of students would see it that way, like that
Better
kind
than,
of
yeah.
common sense. Like I could see a kid writing a really nice paragraph proof. You know, without the statements and reasons. They could write it out in the statements and reasons, but they could write that as just a really nice kind of in a sort of narrative format. And
Right.
it still be. I mean, it's proof. There's evidence. They're justifying it. There's argumentation. I just was wondering, you know, in my 10th grade mind.
That's what
like,
I was thinking the same thing.
Because no people up telling us to write a formal proof, so that's why I was like, what counts?